Kia ora. Welcome to this video that looks at question 2A of the 2009 Scholarship Calculus exam. This is a question that is just algebra and doesn't use any content from level 3 calculus. It's another nice one to do at the start of the year as we get going. And it's looking at a thing called a hyperbolic cosine function. You don't need to know anything about this function at all, except that it's defined like this. So cosh of x is equal to e to the power of x plus e to the negative x over 2. Right, so that's what we're working with. We're being asked to prove that cosh of 3x is equal to 4 times cosh of x cubed minus 3 cosh x. So we're going to look at the left-hand side, get an expression for that, and then we're going to work with the right-hand side and manipulate that until we show that it equals the left-hand side. Alright, so first looking at cosh of 3x. Well, all I do here is I substitute 3x instead of x. Right, so that's all we're going to do with that. So just leave that there. Now, starting on the other side, we've got 4 times cosh of x cubed minus 3 cosh x equals 4 times e to the x plus e to the negative x over 2 cubed minus 3 times this term here. Okay. Now, hopefully you're writing this down as you go, working with that first term, we get 4 divided by 8, 2 cubed, into this, minus 3 over 2, just rewriting that one, e to the x plus e to the negative x. So it just makes it easier to bring the fractions out to the front. Now, remember that if I've got a plus b cubed, I can expand that straight away like this. And that's just using the coefficients from Pascal's triangle, which is another way of saying you're using the binomial theorem. So let's look at what that means here. Well, I've got 1/2 times my a is e to the power of x, and my b is e to the power of negative x. So I've got 1/2 of e to the x cubed plus 3 e to the x squared e to the negative x plus 3 e to the x e to the negative x squared plus e to the negative x cubed minus 3 over 2 e to the x minus 3 over 2 e to the negative x. Right, now the hard work is just about done at this point, but not quite. So we'll go on to the next slide and we'll keep going. Okay, so there's the equation we had on the last slide. I just need to expand out some of those terms. So we're going to get 1/2 times e to the 3x plus 3 e to the 2x e to the negative x plus 3 e to the x e to the negative 2x plus e to the negative 3x, remembering my rules for powers. Okay, so nothing hard there at all. Minus 1/2 3 e to the x plus 3 e to the negative x. Right, so I'm thinking here about putting the 3's back in because I see that eventually I'm going to want to put these two terms together, so it's good to have the same factor outside in the form of the 1/2. Right, so now we can start to chuck some things in together. So that's going to equal 1/2 e to the 3x plus 3 e to the x. Right, so I'm just adding those powers there. Plus 3e to the negative x plus e to the negative 3x. And now I'm going to combine this term. Right, so I've got a plus 1/2 here. I need to have minus 3e to the x. And again minus 3e to the negative x. And I'm left with 1/2 of, well, let's see what goes. I've got a plus 3x here, minus 3e to the x there, so they go. I've got a plus 3e to the negative x here, and a corresponding one there. So I get back to this. Which is equal to cosh of 3x, and we're done. I hope you enjoyed that, and hopefully you'll get a sense that a lot of these problems are actually not that difficult. It's just that you're linking up a whole lot of small ideas from different parts of algebra that you probably haven't put together before. So have a go now at doing that again on your own until you feel like it's an easy question. Alright, and come and see me if you've got any questions. Thanks for watching.